Welcome to MBAs Teach Econ. Today we're going to be talking about the dreaded Solow Growth Model. And I guess to start, it's important to know why we even use the Solow Growth Model. It helps illustrate to economists what sustains long-run economic growth. And by the end of our session, we should see how to use the model to do that. So what we're going to do here is we're going to build the model. But before we build the model, let's get some basic toolkit equations down that will help us along the way. So to start, we all remember our national income accounting identity, also referred to as a GDP equation, which is just y equals c plus I plus g plus x minus m. Last lesson, we also learned about a production function, which tells us that y equals a, which is a factor of technology times a function or mixture of human capital and physical capital. And of course, through our national income accounting, we know that the first equation, this equation, equals this equation. There's two ways to talk about GDP. If we wanted to graph this equation, the production function, let's see what that would look like. So we'd have y on the y-axis, and on the x-axis, let's put k, which is also our physical capital stock. We know from the law of diminishing returns that as we add k into our production function, the increase in y is going to get smaller and smaller as we add more and more k. That's just a classic economic law. So we would expect the function to look something like this, and that's how we'll label it here. The next thing we should talk about is our physical capital stock itself. And we're just going to use a simple relationship. And if we wanted to think about what the stock level would be now, K now, that's going to be equal to what the stock level was last period or last year minus how much of our capital has depreciated. We'll talk about what that means here in a second, plus our level of investment. So when we talk about depreciation, it's basically like when you buy a car. I mean, as soon as you buy the car and it comes off the lot, it loses some value. And there's a certain rate of depreciation that physical capital loses value at for each year. So for the Solow growth model, we're going to use a small d to represent that depreciation rate, and then big K, that would just represent the level of depreciation within the economy. And if we wanted to represent that in our Solow growth model, it would, of course, just be a straight line. And then that straight line is equal to D, our depreciation rate, times K. We can also see another important relationship just looking at this equation here for our capital stock. And we know that K now will be greater than K last as long as investment is greater than D times K. The last toolkit relationship that we'll need to discuss revolves around savings. So if we think about what savings are, it's basically what you take in, your income, minus what you spend. So let's think about how we would represent that in a national setting. So savings are going to equal what you take in, and what the economy takes in as a whole is just y, minus what the economy spends, which would be private spending or consumption and public spending, which would be government spending. This is our simple equation as a starting point when we're thinking about savings. If we plug our GDP equation in for y, we get C plus I plus G plus X minus M, and then we subtract C and subtract G. You can see that the C's and G's cancel out, and you're left with an important relationship where savings equals investment plus your net exports. Often in introductory Econ textbooks, we'll assume that net exports are zero, and then we arrive at an important relationship, especially for the Solow Growth Model, where savings are equal to investment. Let's also think about how we would graph savings. So when we're thinking about savings in an economy for the Solow Growth Model, we use a savings rate. And if we assume a constant savings rate, as long as that savings rate is less than 1, our savings line is basically going to mirror our production function line. It's just going to be a little bit lower. And we would just use a small s to say our savings rate times our big Y, which is our overall production function, or the overall production of an economy. We now have the 3 critical lines that you need to know when you're studying the Solow Growth Model. This concludes the initial setup for the Solow Growth Model. And until next time, it's been MBAs Teach Econ.